next. First one is egg. Different next 1.003. Next ice 1.31. Water 1.33. Kerosene 1.44. Fused quartz is 1.46. Toughness oil 1.47. Chrome glass 1.52. Benzene 1.50. Canada salt, Canada blossom 1.53. Rock salt 1.54. Rock salt. Carbon sulfide 1.63. Dense flint glasses 1.65. Ruby 1.71. Phosphite 1.77. Diamond 2.4. Now I'm going to explain refraction of light at plane surfaces. So first of all, refraction of light at plane surfaces. Plane surface. Now you will see. So first of all, this is a glass slab. This is a glass slab. This is a plane surface. This is a interface. Interface means divides air and glass. This is air, this is a glass. Now you will see this is a beam of light. Beam of light is traveling. This is air takes as medium 1, glass takes as medium number 2. Beam of light is traveling towards medium 2. Beam of light is traveling towards medium 2. So we call this is incident ray. Now next now a part of the this is a point O. This is we call incident ray. This is a point O where incident ray strikes on this point. On this point is called as point of incident. Next, the cycline. This is a cycline drawn perpendicular to plane surface or interface. We call this is a normal line. Next, a part of incident ray gets back into the same medium. a part of incident ray, a part of light ray gets reflected back into the same medium. We call reflection ray. Actually, this is the direction of light ray. There is no glass slab, means this ray goes straight. But this is a medium number 1. This is a medium number 2. What will happen? Light ray travels from one medium to another medium. The light ray is bending towards the normal. This is we call refracted ray. refracted ray. Refracted ray. We call refracted ray. Light travels from one medium to another medium. This ray bending towards the normal. We call this is a refracted ray. Refracted. This is the n. This is the angle between n and I. We call angle of incident. Angle of incident. This is or n. We angle between n and r means we call angle of reflection. Angle of reflection. This is a we call this is a normal line. This is a normal line. Refracted ray. N and R angle between here is we call angle of refracted ray. Angle of refracted ray. This is a actual direction of incident ray. This is a refracted ray. Angle between we call angle between actual direction of incident ray, refracted ray. We call this is the angle of deviation. Angle of deviation. Angle of deviation. Now you will see this is a refracted ray travels again like and strike here. We draw the normal line. Again, it is emergent out. This is a ray, light ray, which emergence out another medium. This is another medium. This is a medium one. This is a medium one, medium two, medium one. This ray which emergence out from another medium. Another medium we call this is a emergent ray. Emergent ray. We call letter is E. This is we call normal and E angle between here we call angle of emergence. Angle of emergence. This is all basic points. All basics fine. Okay. Now you'll see this is a beam of light. Beam of light is traveling towards another medium. We call this is the incident ray. Incident ray strikes at O point. O point is called as point of incident. Straight line drawn to perpendicular to the interface of plane surface is called as normal. Angle between I and N is called as angle of incident. Angle between N and R we call angle of reflection. This is a part of light gets reflected back into the same medium we call angle of reflection. And some other part of the remaining part of the light. This is one part of the light ray get back. One part of light reflected back into the same medium we call reflection ray. The remaining part of the light travels to another medium. In other direction. We call that is a refraction. We call refraction. Otherwise, light deviates, light bending from its actual path or entering into the another medium is called as refraction. Refraction means bending of the light. Actual direction of ray. This is the bending of the light. Light which deviates, light which bending from its actual position on entering into the another medium. Light travels from one medium to another medium. The light bends towards the normal. Refraction means light which bends from its actual direction or entering into another medium is called as refraction. Angle of refraction means the angle between N and R is called as angle of refracted ray. Next, angle of deviation. Angle of deviation means the angle between refracted ray and the actual direction of incident ray. That is the angle of deviation. Next, emergent ray. The light ray which emerges out from another medium we call emergent ray. Angle of emergence means angle between N and E. We call angle of emergent ray. We call angle of emergent ray. Now you will see refraction due to refraction. So refraction due to change of speed. Actually, refraction due to change in speed of light travels from one medium to another medium. Refraction due to ఎందుకు వస్తుందంటే light travels from one medium to another medium. one medium to another medium. ఒక మీడియం నుంచి ఇంకొక మీడియం కి లైట్ ట్రావెల్ చేయడం వల్ల స్పీడ్ లో చేంజ్ వస్తుంది. దానివల్ల రీఫ్రాక్షన్ వస్తుంది. రీఫ్రాక్షన్ డ్యూ టు చేంజ్ ఇన్ స్పీడ్ ఆఫ్ లైట్ ట్రావెల్స్ ఫ్రమ్ వన్ మీడియం టు అనదర్ మీడియం. వన్స్ అగైన్ ఏం చెప్తున్నానంటే ఈ పాయింట్ లో నేను రీఫ్రాక్షన్ దేని వల్ల వస్తుంది, రీఫ్రాక్షన్ దేని వల్ల వస్తుందంటే స్పీడ్ ఆఫ్ లైట్ చేంజ్ అవుతుంది. ఎలా అంటే లైట్ ఒక్క మీడియం నుంచి ఇంకొక మీడియం పోవడం వల్ల, లైట్ ఒక మీడియం నుంచి ఇంకొక మీడియం పోవడం వల్ల స్పీడ్ ఆఫ్ లైట్ అనేది ఒక మీడియంలో స్పీడ్ ఆఫ్ లైట్ వేరే విధంగా ఉంటుంది, ఇంకొక మీడియంలో స్పీడ్ ఆఫ్ లైట్ వేరే విధంగా ఉండడం వల్ల మనకు రీఫ్రాక్షన్ వస్తుంది. రీఫ్రాక్షన్ వస్తుంది. రీఫ్రాక్షన్ డ్యూ టు చేంజ్ ఇన్ స్పీడ్ ఆఫ్ లైట్ ట్రావెల్స్ ఫ్రమ్ వన్ మీడియం టు అనదర్ మీడియం. ఒక మీడియం నుంచి ఇంకొక మీడియం కు లైట్ పోయినప్పుడు స్పీడ్ వేరే విధంగా ఉండడం వల్ల మనకు రీఫ్రాక్షన్ వస్తుంది. Cause of refraction, frequency and phase do not change cause of refraction, but so wavelength and speed both are changed. This is a wavelength and speed both are changes. Light travels from one medium to another medium means light wavelength of light, wavelength of speed, both are changes. This is changes. But here frequency and phase do not change. And light travels from one medium to another medium. Color of light is determined by the frequency, not by wavelength. So frequency means color. Frequency means wavelength. So we have to find out. So color of light is determined by only wavelength. Frequency, not by the wavelength. Light travels from one medium to another medium means frequency, phase do not change. Light travels from one medium to another medium means wavelength and speed of the light is changes. Keep in mind this point. Okay. Next, light travels from radar medium to denser medium. This is air. This is water. This is a beam of light. Beam of light travels towards another medium. We call this is incident ray. This is air. Speed of light in air is 3 to 10 power of 8 meter per second. Speed of light in air is 3 to 10 power of 8 meter per second. Speed of light in a water is 2.5 into 10 power of 8 meter per second. Your speed is more, your speed is less, and refractor ray bending towards a normal, towards the actual direction of incident ray, this one. But here refractor ray bend towards a normal, because this is a refractor ray. This is the actual direction of incident. This is a refractor. Speed of light in a water is speed of light in a water is 2.5 into 10 power of 8. Speed is more. This is taken as radar medium. Speed is less means this medium taken as denser medium. Now you'll see bending of the light. This is a normal line. This is a normal line. Refractor ray bending towards the normal. Refractor ray bends towards the normal. Angle of I greater than angle of R. You see, angle of I is greater. Here angle between N and I. We call this is angle of reflection. Angle of I is greater than 2 angle of R. We call this is the next condition, deviation. Deviation means angle between the actual direction of incident ray. This is a refractor. We call deviation. Deviation is equal to angle of I minus angle of R. Angle of I minus angle of R. This is a light travels from radar medium to denser medium. Now next, light travels from Next, light travels from, this is a dense, this is a water, this is a glass. Speed of light in a water is 2.5 into 10 power of 8 meter per second. This is a glass, 2 into 10 power of 8 meter per second, speed of light. This is this one, this is more speed, this is less speed. More speed means you take, this is a rarer medium, rarer medium. This is less speed means denser medium, denser medium. Light travels from, okay, you take, this is a glass, water. This is 2 into 10 power of 8 meter. This is a denser medium, denser medium. This is a 2.5, 2.5. This is a rarer medium. Now light travels from, beam of light is traveling towards another medium because this is an instant. This is a normal angle between here is because angle of incidence, angle of incidence. This is the actual direction of incident. But here water, here glass, here water, the light is bending away from the normal, away from the normal, away from the normal. This is refractory rate. This is angle of this is we call, this is a deviation. That is a deviation. Now you'll see, this is a speed of light. Here speed of light is 2.5 into 10 power of 8. This is this medium taken as a radar medium. Speed of light in a glass is 2 into 10 power of 8 meter. This is taken as a denser medium, denser medium. Keep in your mind, this is a 2.5 into 10 power of 8 meter per second. Here speed of light is 2 into 10 power of 8 meter per second. More speed, less speed. More speed taken as always radar medium. Less speed taken as a denser medium. Keep in your mind. Now, so next, this is a refractor ray. Refractor ray moves away from the normal first point. That is important. Refractor ray away from normal, away from normal. Next, second point, angle of deviation. Angle of deviation is called angle of minus angle of phi. Angle of r greater than 2, angle of phi. Okay, this is a deviation. This is a deviation. Keep in your mind, light travels from denser medium to radar medium. Light travels from denser medium to radar medium means refractor ray bends away from the normal. Deviation, angle of deviation is equal to angle of r minus angle of phi. Keep in your mind this one. Now, next, no deviation. Condition for 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 no deviation. No deviation or bending. Condition for no deviation and condition for no deviation for no deviation. Now we will see, this is a rarer medium, denser. Rarer medium, denser. We call this is a normal line. This is a normal line. Normal line. Next, incident ray. This is a incident ray. Incident ray strikes normally at the point of incident. And this is a normal line. Normal line. This is an incident ray. Incident ray strikes normally at the point of incident. Point of incident. It does not deviate from another medium. It goes straight. It goes straight. There is no bending. Now, this is a denser medium. This is a light ray, incident ray. Incident ray strikes normally. Incident ray strikes normally at the point of incident. It does not deviate from another entering into another medium. It goes straight. No deviation. Angle of r is equal to angle of I. Angle of I is equal to angle of r. Here angle of I is equal to angle of r. Both are equal. There is no deviation. Next, suppose this is a air. This is a air. Here also inside air. Here also air. Here also air. This is a mu. Mu 2 is equal to mu. Medium 1, medium 2. Now this is a beam of light. Beam of light is traveling another medium. We call this is incident. Incident ray. Here also air. Inside also air. This ray goes straight. This ray goes straight. Here angle E. Here angle of R. Angle I is equal to angle of R. There is no deviation. There is no deviation. This is the condition for no deviation. Condition for no deviation. Condition for no deviation. Now we will see next one. Next, refractive index. Refractive index. Next, loss of reflection. Loss of refraction. Refraction. Loss of reflection. I, instant ray, normal, reflection, all are always lies in a same plane. Lies in a same plane. This is a first law. This is a first law. Second law, mu, Snell's law. Snell's law. Snell's law. That is a mu sin I is equal to constant. Constant. Mu 1 sin I1 is equal to mu 2 sin I2. You can write this one. Sin I1 by I2 is equal to mu 2 by mu 1. This is we call Snell's law. We call Snell's law. We call Snell's law. Okay, this is the Snell's law. Okay, come to the point. Next point. Snell's law. Refractive index. What is meaning of refractive index? You see the mu means refractive index. Refractive index. Mu indicates mu or you can take n letter. Refractive index. In your book, the book having n notation. N means refractive. N means refractive index. Here, this is n. You can write 2 1 or you can write this is the n2 1. This is we are going to write absolute refractive index. So first of all, I'm going to explain absolute refractive index. Absolute refractive index. Refractive index. Absolute refractive index. Very simple. Absolute refractive index means mu is equal. Letter is mu. Mu is equal C by B. C by D. This is a absolute refractive index. Absolute refractive index. Mu is equal to, sorry, you can take this is a n letter. In your book having n notation, you can write. N is equal, C means speed of light. Speed of light in a free space. Free space or vacuum or vacuum. Vacuum you can write. By next V means speed of light in a medium. So n means refractive index is equal the ratio of speed of light in a free space or vacuum to the speed of light in a medium is called as absolute refractive index. Absolute refractive index. N gives refractive index gives us how much speed of light fast, how much speed of light slow in a medium. Medium లోపల స్పీడ్ ఆఫ్ లైట్ ఎంత ఫాస్ట్ గా ఉంది లేకపోతే ఎంత స్లోగా ఉంది అనే ఐడియా గురించి రిఫ్రాక్టివ్ ఇండెక్స్ gives us idea how much fast or how much slow speed of light in a medium. Refractive index gives gives us idea how fast, how slow speed of light in a medium లోపల speed of light fast గా ఉందా, slow గా ఉందా, ఫాస్ట్ గా ఉందా అనేది మనకు ఇన్ఫర్మేషన్ ఇది ఇస్తుంది. మనకు ఇన్ఫర్మేషన్ రిఫ్రాక్టివ్ ఇండెక్స్, అబ్సల్యూటివ్ రిఫ్రాక్టివ్ ఇండెక్స్ ఇస్తుంది. నెక్స్ట్ రిలేటివ్ రిఫ్రాక్టివ్ ఇండెక్స్. రిలేటివ్ రిఫ్రాక్టివ్ ఇండెక్స్. ఇన్ అబ్సల్యూటివ్ రిఫ్రాక్టివ్ ఇండెక్స్, so n is equal c by v. C by c. C is equal to, we know v is equal to f lambda. C is equal to f lambda. C is equal to f lambda. V is equal to f lambda. C means free space, ante vacuum. Vacuum. This is a medium. This is a vacuum. Frequency constant, but wavelength are different. Speed also different. Now n inversely proportional to the v, inversely proportional to the lambda. You can write this. Now you can write this one. Keep your mind, this is the point is very important. Now n means refractive index, inversely proportional speed, inversely proportional to the wavelength. Now you will see relative refractive index. Relative refractive index. Relative refractive index. Relative refractive index. Refractive index. Relative refractive index is equal to n21, or n21 is equal speed of light in a medium 1 by speed of light n21 is equal speed of light in a medium 1 by speed of light in medium 2. Now we will see, so medium 1 means I'm checking V1, this is a medium 2 means V2, this is a N21 or now R or R, this is a N21. What is the meaning of this one means? You will see, I will explain. I'm checking V1 by C by V2 by C and divide the C by C. V1 by C, V2 by C. I'm dividing. Now you will see absolute refractive index means n is equal C by V. This is a V1 by C. I'm going to write this is a 1 by n is equal to V by C. I'm writing V1 means this is a V1, this is N1 I'm checking. Now this is I'm writing. Now you will see 1 by n V by C. V2 means this is N2 I'm writing. V2 by C means I'm going to write 1 by N2. 1 by N2. This is N21 or R. This is N21. Now I'm going to write this is N2 by N1. This is a N2. Sorry. This is a N2 by N1 is equal. You can write this is a n inversely proportional. V means I'm writing this is V1 by V2. That is equal to, so 1 by lambda. This is a N21 or R. This is a 1 to now. You can write that. Now second equation also. You can write this is a N12 is equal R or R. N12 is equal N1 by N2 is equal V2 by V1 lambda 2 by lambda 1. This is a formula. Very important. Very important. This is a relative refractive index. Relative refractive index. So meaning means what is the meaning of that one means N21 is equal for R is equal N2 by N1 is equal V1 by V2 is equal lambda 1 by lambda 2. That is safe. What is the meaning of this one? Means this is N refractive index 2 with respect to 1. Refractive index medium 2 with respect to medium 1 is equal speed of light. Speed of light medium 1 with respect to speed of light with medium speed of light medium 1 with respect to medium 2. This is a wavelength of medium 1 with respect to medium 2. Next, this is 1 2 R. This is 1 2. So N1 by N2 is equal to V2 by V1 is equal to lambda 2 by lambda 1. Now this is you see refractive index. Refractive index medium 1 with respect to medium. Refractive index medium 1 with respect to medium 2. Refractive index medium 1 with respect to V2. V2. Speed of light medium 2 with respect to medium 1. That is your formula. That is your formula. Keep in mind that is very important. Now, so we have the material and refractive index combined. Once again, this is a relative refractive index. Relative refractive index means this is a N means refractive index medium 2 with respect to medium 1. Refractive index medium 2 with respect to medium 1. Speed of light in medium 1 with respect to medium 2. Refractive index medium 2 with respect to medium 1 is equal speed of light medium 1 with respect to medium 2. Now we will see speed of light, refractive index medium 1 with respect to medium 2, speed of light medium 2 with respect to medium 1. That is our formula. Keep in mind that is very important. Now we will be confident. I will see this is important. Keep in your mind. Now I will see. Now this is I am going to write. This is a 1 2. This is a 1 2. Speed of light in medium medium 2 by speed of light in a medium 1. This is a refractive index medium 1 with respect to medium 2. Speed of light medium 2 with respect to medium 1. Medium 2 with respect to medium 1. Medium 2, this is a medium 2 by medium 1. But here, refractive index medium 1 with respect to 2. This is a 1 2. This is a 2 by 1. This is a 2 1. This is a 1 2. This is a 1 2. This is a refractive index medium 2 with respect to 1 means speed of light in a medium 1 2 2. This is a 1 2. Refractive index 1 2. This is a medium 2 with respect to medium 1. This is a refractive index, relative refractive index. That is the formula. Keep it in mind. Now, you will see some examples of refractive index. Okay. Now you will see material medium refractive index, material medium refractive index. You will see this is a refractive index. A refractive index is 1.0003. This is a least value. Material refractive index is less. Now you will see diamond. Material medium is diamond, but refractive index is 2.4. This is highest value. This is a high value. This is a low value. Air means material medium, refractive index this value. Diamond, material medium, diamond, refractive index is 2.42, highest value. Least value, highest value. In this material medium, you will see ice, water, kerosene, fused quartz, turpentine oil, chrome glass, brenchane, Canada blossom, rock salt, and carbon disulfide, dense flint glass, ruby, and serpentine and diamond. We have the material medium, and this is a refractive index value. Now I'm taking just two examples. First example. Why I'm going to explain, you see that. Water, I'm taking the corrosion. Refractive index of the water, NW is equal to 4 by 30. This is a refractive index of the medium. Yan glass is equal to 3 by 2. 3 by 2. Refractive index of the glass is equal to 4 by 30. Refractive index of the glass is equal to 3 by 2. That's right. Now, okay, look, just water. What is the refractive index? Refractive index. Water refractive index value is 1.33. Next to corrosion. Refractive index is 1.44. Refractive index 1.44. This is a refractive index value. You will see compare water and corrosion. Refractive index is more refractive index is corrosion greater than 2. Water. This is our point. Refractive index of corrosion is greater than 2. Refractive index of the water. Now you will see. Next, density is equal to mass by 1. Density mass density mass density of corrosion. Density of corrosion is equal to, I'm assuming keep density of water is equal to SI into 1000 kg meter cube. Now I'm thinking. Now density. Now you will see corrosion takes as corrosion is taken as denser medium. Now we will see which one is greater here. Water is greater than 2 corrosion. You will see that. The refractive index of corrosion is greater than 2 refractive index of water. But density mass of the water greater than 2 mass density corrosion. Mass density is greater water. Refractive index is corrosion. But corrosion is taken as a denser medium. ఏమని చెప్తున్నాం ఇక్కడ వాటర్ corrosion కి refractive index కంపేర్ చేస్తే corrosion కి refractive index ఎక్కువ, కానీ మాస్ డెన్సిటీ పరంగా వాటర్ కి మాస్ డెన్సిటీ ఎక్కువ corrosion కంటే. అందుకని corrosion is taken as a denser medium. This is a material medium. Refractive index value. This is water. Now, that is your class. Next. Okay, now, understand? This is a refractive index of water is 4 by 3. Refractive index of glass is value. Density mass corrosion is this value. Density water value is this one. Density mass water is greater than 2. Mass density corrosion is less. This is the water refractive index of water. Refractive index of corrosion. Refractive index of the corrosion is greater than 2 refractive index of the water. but kerosene is taken as a denser medium. Yes, denser medium taken. Okay. Next, here refractive index is universally proportional to the speed of light in a medium and universally proportional to the wavelength of wavelength in a medium. Next, activity 3, refraction. Activity 3, you will see activity 3. Now, so you will understand refraction. Refraction. Now you will be understand refraction. So refraction refraction. So light ray which deviates or bending light ray which deviates or bending from its path, from its original path, from its original path, while passing from one medium to another medium. Light ray which deviates or bending from its original path while passing from one medium to another medium. Bending of the light. Light ray travels from one medium to another medium. Bending of the light ray. Light ray which deviates or bending from its original path while passing from one medium to another medium. Entering, passing, or entering. You can write entering or passing. Okay. Both are same also. That is a refraction. Now you'll see, you will take the shallow vessel. Now you will see, this is a vessel, shallow vessel. So this is a wall. This wall aperture means light does not allow through them. That is the aperture medium. Now you will see, and point of this coin is placed at the bottom of the shallow vessel. Now you will stand the back outside of the here. So you cannot see so first I consider shallow vessel and coin kept at the bottom of the vessel. Now I'm standing outside of the vessel. Now I'm moving away from the vessel. I cannot see the coin up to I should be move away from the coin, away from the vessel. Now I'm not seeing to the coin. I'm standing. Now, so next I want to fill the vessel. Vessel filled with water. Vessel is filled with water. This vessel filled with water. Now, so vessel filled with water means I'm standing here. I'm seeing the coin. Here I'm not seeing to the coin. cannot see the coin. This is a vessel is empty. This is a shallow vessel. This is a shallow vessel. Coin kept bottom of the vessel. I'm standing away from the vessel. I'm standing away from the vessel, but still I'm not seeing to. I'm not seeing to the coin. I'm not seeing to the coin. Okay, next case is so vessel is filled with water. Vessel is filled with water. Now I'm seeing to the coin. I'm seeing to the coin. So here vessel is empty means I'm not seeing to the coin, but vessel is filled with water, but I'm seeing to the coin. But what is the reason? What is the reason? Due to refraction. Due to refraction. Simple refraction. How it's possible? You will see that. Now this is already I told you very clearly. Conditions. Light travels from basic point. Light travels from radar medium to denser medium to radar. This is you take radar medium, denser. Light travels from radar to medium to denser medium is refractory bend normal. Refractor. This is I. This is R. Refractory bends towards the normal. Next, light travels from denser medium to radar. This is a denser. This is a radar. Away from the normal. Away from the normal. Refractory instant. Right. This is a two situation. Now we will see. This is a water. This is a water. This is a outside is air. Air takes as a radar medium. Radar medium. Water takes as a denser medium. Denser medium. Already I told you. So why we are taking to the denser medium radar? Speed of light is more in air. Air takes as a radar medium. Speed of light in air, water is less compared to the air. This water taken as a denser medium. Denser medium. Now you will see light travels from. You will see this is now you will see this is I'm taking normal ray. This is an interface line. Now we'll see the coin passes the rays. The coin passes ray. This ray is travels from denser medium to radar. This is a denser medium. This is a radar medium. You will see denser medium to radar. Light travels from denser medium to radar means away from the normal. This is a line. You take the normal. This is the actual direction of instant ray. But this light ray travels from denser medium to radar medium means bending away from the normal. Away from the normal means you see bending away from the normal. You see, he is seeing to the coin. He is seeing to the coin. But you will see actually he is seeing to the side. This coin appears rising in a water. Appears rising in a water. Now we will see. Is seeing straight. Is seeing to the side. You see, is seeing to the and is seeing to the coin. Is seeing to the coin, but he is not seeing to the original coin, but he is seeing to the coin appears rising. He is seeing to the rising coin, but he is not seeing to the actual coin. He is seeing to the coin appears rising. He is seeing to the rising coin due to refraction. That is a refraction. Once again, I'm going to explain that one. You see much clearly? I'm going to explain refraction. Refraction means light which deviates or bending from its original path while passing from one medium to another medium. This is a basic point. Light travels from radar to denser means refracted ray moves towards the normal. Light travels from denser medium to radar medium, refracted ray away from the normal, away from the normal. I'm checking to this is our first example, shallow vessel, shallow vessel. This is a wall. This is wall number one, wall number two. Two are opaque walls. Opaque walls means I'm standing here. I'm not seeing through. I'm not seeing inside. Inside, what will happen? Opaque wall. It is not a transparent glass. It is not a transparent glass. Okay, now I'm standing here. I'm standing here. This is a shallow vessel. Next, I'm taking to the coin. This is a 5 rupees coin. The coin kept the coin keeps at the bottom of the vessel. Bottom of the vessel. I'm standing outside of the vessel. I'm not seeing to the coin up to. I'm moving away from the coin. Moving away from the coin. This is a vessel. This is a coin. Coin kept at the bottom of the vessel. This is a person standing outside of the glass. This person move away from the vessel. You cannot see the coin. You cannot see the coin. Okay. Next, and this vessel filled with water. This vessel is filling with water. Filling with water up to this level. Up to this level. Now this person is seeing to the coin. This person cannot see the coin. Reason, this vessel is empty and this person is standing away from the vessel. He cannot see the coin, but he is seeing the coin. Same places, but he cannot change the position. He cannot change the position. So where he is standing, the place only, he is seeing the coin. This situation, he cannot see the coin, but in this situation, he is seeing the coin. This vessel is empty. This vessel is filled with water, but he is seeing to the coin. But he is not seeing to the coin. Vessel is empty, and at this position does not change. You see that one, and the vessel is filled with water. Now you will see. Now this is we call interface. This is we call normal light. Normal light. This is a coin. Releases ray, one ray. Actually, this ray is ghost sight. Ghost sight. This ray is a ghost sight. This ray is a ghost sight. This ray is ghost sight. But this is a denser medium. This is a rarer medium. Light travels from denser medium to rarer medium. This is a denser medium, rarer medium. What happened? This is incident ray. This is a reflector away from the normal. Away from the normal. This ray is bending this direction. Now you will see he is seeing to the this coin. This is a coin. This is ray is coming from coin. He is seeing to this side. He is seeing to this side. Now this is a coin. He is seeing to the coin, but he is seeing to the rising coin. But he is not seeing to the actual coin. Actual coin. He is seeing to the coin. Coin rise. Coin appears rising coin. He is seeing. Now this is a. Thank you. Thank you. Thank you. Thank you.